Hi guys, welcome. We're looking at week 8, and we only have one lesson this week because we're going to be finishing up this unit and going over the review. So we're looking at surface area of right pyramids and of cones. So again, surface area, we're still looking at area. So if you're good at drawing these nets, that's going to really help you out. Yeah, if we have a square base, a pyramid, we know we have square and then 1, 2, 3, 4 congruent triangles. So the slant height of the pyramid ends up being the height of our triangle. So that's where sometimes getting confused on base area, heights, and slant heights. We just really have to be careful making sure we're using the correct terminology and understand what's being asked. So the apex is directly above the center of its base. So that up there, that would be the slant height would be the height of our triangle, not the height of our pyramid. So just be aware of that. The lateral surface area of a pyramid is composed of triangles. To find the area of one triangular face, we multiply the length of a side, a base, by the slant height divided by 2. So again, it looks very confusing, but we've done area of a triangle since the beginning of the year. Base times height divided by 2. So that's where we get it. To find the lateral surface area, we have a choice. For the pyramid, we could find the area of one of the face and multiply it by 4. Alternatively, we could multiply the perimeter of the base by the slant height and divide the product by 2. So a couple different ways. If you just prefer draw the net, do it the old-fashioned way, add them all up, and be done. We know there's 4 of these same triangles, so we can just multiply by 4, and 4, okay, is going to be the perimeter times the slant height, because 4 times the length of the side, since it's a square, 4 times the side is the perimeter, so that's where we get perimeter times this S. I think in our reference sheet it has cursive L or whatever, so that's the slant height, and then divided by 2. So lateral surface area of a right pyramid. Okay. I use LSA for lateral surface area. If you want to use A of S, that's fine. The P is the perimeter. S is the slant height. So 1/2 perimeter times the slant height, or perimeter times the slant height divided by 2. So either one, I'm not sure. I don't think any lateral surface areas are on your reference sheet. So if you want to add this, or when we get to class, we'll go back over and I'll let you guys take a few minutes to put this onto your reference sheet, just so you have it. Again, if you get in a bind, just draw it out and find the area, multiply it by 4, and then find the area of the square. It's if we're talking about surface area or lateral surface area, you know how to do those just by breaking apart into different polygons. But this may save you a little bit of time. To find the lateral surface area of a right pyramid with a slant height of 10 and a regular hexagonal base with 5 centimeter sides. So we got to find the perimeter. Hexagon means we have 6 sides, so 6 times 5 is 30. So that's our perimeter, times the slant height of 10. We're given that. If we weren't, we'd have to go in and break it into its own right triangle and find it. But we're given the slant height. So 30 times 10 divided by 2. So 30 times 10 is 300, divided by 2 is 150. Okay, or we could have found the area of one of the faces. We know there's 6 congruent faces, so we could have multiplied the 25 square centimeters times 6 and got the same thing. To find the lateral surface area of a right cone, we may use the same concept we used for the pyramid because it's coming to a point. Again, so we can substitute circumference. Circumference is pi times diameter, or 2 pi r. We'll use the second formula. So 2 pi r, that's the circumference, times the slant height divided by 2, but then 2 over 2 cancels out. So we're left with pi times radius times the slant height. Okay, R is the radius, S is the slant height, and this A of S is our lateral surface area. So again, you can put this on your reference sheet if you would like. I'll probably remind you guys in class, as I'd like to fill them in as we go as well. So we need to know the slant height and the radius and plug it in. Okay, so if we're looking at this one right here, find the lateral surface area and the total surface area of the cone. Okay, so the height is 12, the slant height is 13. It looks like it's not drawn too clearly, but it looks like the diameter is 10 centimeters. Okay, so that means the radius is 5. So pi times 5 times the slant height. 3.14, we weren't told, but we used 3.14 times 5 times 13. Okay, they're leaving it in terms of pi. So if you use 3.14, I got 204.1. 65 times pi is 204.2035225, and continuing on. So they didn't tell us to leave it in terms of pi. So if you did either one, that's fine. But we were given the slant height, the height, and then the diameter. So the radius is 5. And they didn't do a very good job of indicating. They just have this number up here. Doesn't really tell us what that is, but assume it's the diameter. Okay, so then that would be the lateral surface. Then we would have to find the area of the circle and add that to the lateral surface area. So just area of a circle, pi r squared, 3.14 times 5 squared, so times 25, 78.5, or 25 pi if we're leaving it in terms of pi. And we add those two together for total surface area. All right, this practice set we'll go over again. Those two in lateral surface area, if you want to use this, just be aware that the slant height on our sheet, I think, is the lowercase cursive L, but I'll double check when we get to class. Just make sure you write it in a way that it makes sense to you. Copying these but having no idea what any of it means doesn't do you any good. And the practice set problems, we will go over those as a class, get reviewing for this unit.